already in your lower classes you have studied about refraction of light. So we have learned about refraction of light through a triangular prism, that is a equilateral prism. So here I have a ray diagram drawn for you. If you observe here, a ray of light is coming from a light source. I have a slit here. Slit is a small opening, understood? So that we should get only one or two rays of light. Now I have taken only one ray of light. This ray of light is incident on one refracting surface of the prism. We know that the prism has two refracting surfaces, is it not? So this is the first refracting surface and this is the second refracting surface, and this will be the angle of prism. Now I have taken a light ray from the light source, and this light ray is incident on one refracting surface of the prism. And we have already studied about this phenomenon of light in 8th standard, is it not? Where the light will undergo refraction. That is, the light will suffer deviation in its path because the light ray is travelling from one optical medium to the other optical medium. So here, if you observe, the light ray undergoes refraction and it passes through glass. This prism is made of glass, and again it will come out to the first medium only. So it will undergo refraction twice. This ray is called the incident ray, is it not? And this will be the refracted ray, and this will be the emergent ray. Okay. Now here, this diagram, if it is observed, then we will come to know that the light ray is getting deviated from its path. Now I have shown the dotted line. This dotted line represents the original path of the incident ray. Now, as you observe, see, there is a deviation, means the light ray bends and changes its direction. This will be the refracted ray. It passes through glass, and again, once again at the second refracting surface, the light ray will suffer further deviation and it comes out in the air. So if I take this medium as air, this as glass, okay, the light ray enters from air to glass and again comes back to air. So here we can observe that the light ray is undergoing refraction 2 times, and both the times there is a deviation observed in the path of the light ray. So in this topic we are going to study about the deviation produced by a triangular prism. This is the concerned ray diagram. Here if you observe, I have marked the angle of incidence I, is it not? And this will be the angle of emergence, and the given deviation also is taking place. I have drawn the incident ray. I have produced the incident ray forwards and emergent ray backwards, understood? And if you observe here, this angle is called the angle of deviation. So this angle is called the angle of deviation, understood? So 2 times the deviation is taking place, and these 2 angles I have noted them as delta 1 and delta 2. So remember that whenever light enters from air to glass and again comes back to air, then how many times the light ray will undergo deviation? 2 times the light ray will undergo the deviation. Now, so the total angle of deviation is represented by the letter delta. This letter delta is equal to delta 1 plus delta 2. So because 2 times the deviation is taking place, and hence the total angle of deviation will be equal to delta 1 plus delta 2. Okay, and it is observed that the total angle of deviation depends on certain factors. Now, which are those 2 factors? Which are those factors you see here? The total angle of deviation depends on the angle of incidence at the first surface. So, the angle of incidence at the first surface. Here I have shown in this diagram angle of incidence. So, depending on the angle of incidence, the total angle of deviation also depends. So, the deviation changes as the angle of incidence also changes. Then, the angle of deviation depends on the angle of prism. Angle of prism is this one here, I have shown here. So if you take equilateral prism, then the angle of prism will be equal to 60 degrees, is it not? And moreover, not only equilateral prisms, we have various other types of prisms like 30, 60, 90, right angle isosceles prisms we have. Understood? Then 45, 45, 90, like that, two or more types of prisms are also there. So depending on the angle of prism, the angle of deviation also changes. And the third factor is refractive index of the material of the prism. So, with what material the prism is made of, that is also very important. So, already we have learned that every medium has got some refractive index, and the deviation depends on the refractive index of the material of the prism. So, these three factors you have to remember. So, angle of deviation depends on the angle of incidence at the first surface, the angle of prism, that is A, and the refractive index of the material of the prism. Okay. Next, coming to the dependence of deviation on the color or wavelength of light. We know that when light is traveling through vacuum or air, the light, which is consisting of 7 colors, all the 7 colors will be traveling with the same speed. Like we have violet to red, all the 7 colors will have the same speed when the light is traveling through vacuum or air. But when the light ray enters any other transparent medium like glass, like here I have taken a prism, then what happens? The velocity of each color changes when they enter the prism or the medium. Now, that one we have to understand here. So, here what is happening, you see? With the decrease in wavelength of the color, means as the color changes, means as the wavelength changes, what happens to the velocity? Velocity will also change. So here wavelength is decreasing and hence velocity also decreases. Now if you take all the 7 colors from violet to red. So violet, indigo, blue, green, yellow, orange and red. Then which is having the minimum wavelength? Violet is having the minimum wavelength. Okay. This wavelength is a minimum, whereas the wavelength of red light is maximum. The wavelength of red light is maximum. So here you must remember these points have been noted down only after observation how the light ray will behave when it enters any other medium from vacuum or air. So as the wavelength of light decreases, what happens to its velocity? The velocity also decreases. Now, with the decrease in the wavelength, what happens to the refractive index? Refractive index will increase. Now, why I have shown downward and upward arrow marks means downward arrow mark will represent decrease, whereas upward arrow mark will show increase in the quantity. So, first point what we have done? As the wavelength decreases, the velocity also decreases. Velocity of the light will decrease. Now, with the decrease in wavelength, what is happening to the refractive index? You see, refractive index will increase. This already we have learnt as the refractive index of the glass increases, what happens to the wavelength? Wavelength will decrease. Now, as the wavelength of the light decreases, what happens to the angle of deviation? The angle of deviation will increase. So, these are the 3 very important points you have to remember whenever light enters from one medium to the other. So, what is the first point you have to remember? The wavelength of, as the wavelength of the light decreases, the velocity also decreases. And with the decrease in the wavelength, the refractive index will increase. And as the wavelength decreases, the angle of deviation will increase. Now, you have to note here, the angle of deviation is more when for violet is more when compared to that of red. Understood? So, here I shall change the color only so that you can find out better. The angle of deviation for violet will be greater than the angle of deviation for red. When you compare the wavelengths, the wavelength of red light is more than the wavelength of violet light. And one more important point what you have to remember is the refractive index for violet is more than the refractive index for red color. Understood? So, because of the decrease in wavelength, the velocity changes, and due to the change in the refractive index, the velocity also changes and even angle of deviation also changes. These important points must be remembered whenever we study about the deviation of light ray through a triangular glass prism. Understood? So, remember that the angle of deviation for violet light is more than the angle of deviation for red light. And also you must remember that the wavelength for red light is greater than the wavelength of violet light. Therefore, the refractive index of the medium for violet is more than the refractive index of the medium for red light. Understood? And what is the wavelength of violet light? The wavelength of violet light is around, see, wavelength of violet light is nearly 4000 angstrom units. Okay. So 1 angstrom unit will be equal to 10 to the power minus 10 meters. Next, what is the wavelength of red light? The wavelength of red light is 8000 angstrom units. So if you take visible light has 7 colors, violet to red, and what is the range of wavelength? The range of wavelength for visible light is 4000 angstrom units to 8000 angstrom units. 4000 angstrom units is for violet light, whereas 8000 angstrom units is for red light. So, this is about the dependence of deviation on the color of light. So, as the color changes, what happens to the deviation? See, deviation of violet light is maximum when compared to deviation of red light. And for other colors, it will lie in between. So, this is about deviation of light produced by a prism. Okay, children. So, we have learned about the dependence of deviation on the color of light. As the color changes, what happens to the deviation? The deviation also changes. It has been observed that the deviation of violet light is more when compared to the deviation for red light. Next, we have to study about dispersion of white light through a prism. This topic also you have already learnt in 8th standard. So, here what we are going to study? We are going to study about the dispersion of white light. Whenever white light passes through a transparent medium like glass, then what happens? All the 7 colors which are present in the white light, they will split, is it not? So there is a splitting of 7 colors when white light enters from air to glass. So this ray diagram will show about the splitting of white light into 7 colors. Now, already I have told you this will be the first refracting surface, and this is the second refracting surface of the prism. Now, if I draw normal here, right? If I draw normal, then you can observe that the light ray is splitting into 7 colors when it enters the first refracting surface of the prism. Now, into 7 colors means I have drawn here violet light and red light only, and other colors will lie in between violet and the red color, which I have not shown in the diagram. So, all the other colors will be splitting here and they will come out of the prism. Understood? I have a screen here on which all the 7 colors will be incident. So, at the first refracting surface, you can observe that there is deviation taking place, is it not? Deviation is taking place, even refraction is also taking place. So, 2 phenomena takes place at the first surface. What is happening? Deviation, then dispersion, and also refraction. All the 3 will take place at the first refracting surface. Now, this is the incident ray produced. Okay, this should be the path of the incident ray. Instead, what is happening? The light will split into 7 colors, and these 7 colors will travel through glass, and through the second, when they are incident on the second reflecting surface, these colors will suffer refraction again and they will undergo deviation. Okay, so here at the first reflecting surface only dispersion will take place, whereas at the second reflecting surface only refraction and deviation will take place. Now you can observe here from the incident ray which I have produced, you can observe that red is also undergoing some deviation and even violet is also undergoing some deviation. If you observe in this diagram, the angle of deviation for violet light is more as compared to the angle of deviation for red light. So this phenomenon wherein white light, ray of white light splits into its constituent colors whenever it enters through a transparent medium like glass is called dispersion of light. And as you all know, this dispersion of light was first discovered by Sir Isaac Newton. Is it not? And all the 7 colors which are obtained due to dispersion of light is called the spectrum. And we call it as visible spectrum. Now why it is called visible spectrum means because this spectrum is of visible light. Visible light means the light which we can see, means which is surrounding us. This visible light, with its help only we are able to see all the objects around us. So this visible light is split into 7 colors. Understood? And the band of 7 colors is called a spectrum. Now here you must remember that a prism will only split the colors into its constituent colors. The prism will split the white light into its constituent colors, but the prism will not produce any color of its own. So what the prism is doing? The prism will just separate the constituent colors of white light, but it will not produce any new color on its own. Understood? This has to be remembered. Okay. So this is about the dispersion of white light through a prism. In our next session, we shall study about the angle of deviation for violet color and angle of deviation for red color. Understood? So once again we shall revise about the dispersion of violet light through a prism, and we shall go for further topics. So remember that this band of 7 colors which is obtained due to dispersion of light is called spectrum, which is named as visible spectrum. Okay children, thank you.